So coming to this number systems, first we will start with number systems called binary number systems. Binary number systems. So if you want, you can write your running notes if you wish, or else I will try to provide the notes in the end of this session, or anytime when I am free, I will provide the notes for this. It's upon your wish. It's your wish to whether to write running notes or printed notes you wish. Okay. Yeah. So coming to these number systems, we have binary number systems, hexadecimal numbers, hexadecimal numbers, and we have decimal numbers, and we also have octal number systems or octal numbers. Yeah. So these are the type of numbers or type of number systems we have in this: binary numbers, hexadecimal numbers, decimal numbers, and octal numbers. So before going to this, so we should know these two terminologies. First one is the number, and the next one is base. So this base decides in which category the number falls into, whether it will falls into binary number systems, or it will fall into hexadecimal number system, or it will fall into decimal, or it will fall into octal. So the base will decide the number which group it will fall into. So coming to this binary number systems, the base will be equal to 2. And coming to this hexadecimal numbers, the base will be equal to 16. And octal, the base will be equal to 8. And decimal, the base will be equal to 10. So say suppose if the number 5 to the base 10, so this represents the number is a decimal number. And say suppose 1 to the base 2, it means a binary number system. And let's say suppose 7 to the base 8, it is an octal number system. It is an octal number. Okay. And 15 to the base 16, it is a hexadecimal number. Hexadecimal number. So this is a different type of numbers we have in uh, digital. Okay. So observe here. Let's say suppose 2 to the base 8, then it is an octal number. So the rule here is the number should not exceed the base. So say suppose in octal numbers, the last number can be of, so 1 to the base 8, 2 to the base 8, up to, we can write up to which number? So the rule is that this number should not exceed the base. So up to how many numbers we can get? 7, right? Is this clear?
Mm.
What I wanted to
Yes.
tell is clear, right? Yeah. So similarly, with base 2, how many numbers we can form? 2, right? 0 and 1. Is it clear? And hexa,
Yes.
we can form from 0 to 15. In the case of decimal, it's different. Decimal number systems are the number systems which we use in our daily life from 0 to infinite. These are our daily routine numbers, and these are different numbers. So these numbers follow this property. So the base, these numbers should not increment their base digit. So for octal numbers, the range is from, so from this we can write the range of octal numbers is from 0 to 7. So this is a important point. So you should remember this. So the range of octal numbers is 0 to 7, and the range of binary numbers. The binary numbers are used mostly in our computers. So binary language, zeros and ones. So these are used more in the digital. So the range of binary numbers are 0 and 1. That's it. And coming to hexadecimal, the range is from 0 to
15.
So in case of hexadecimal numbers, we don't write 10, 11, 12, 13, 14, and 15 directly. So for this, we have separate notations. So for 10, we have a notation called A, and for 11, we have a notation called B, and 12, we have a notation called C, 13 D, 14 E, and 15 F. So now the range of hexadecimal numbers is from 0 to F. F means 15. So in starting, when you're starting with the digital, so it will be somewhat difficult to remember these notations. So you can write it somewhere on the side when you are doing any problems. So you can write these notations on the side of some paper, and you can solve the problems. So is the range and introduction to different type of numbers, is it clear? Are you having any doubts? Yeah. So now let's start with the decimal numbers. Decimal number systems. So decimal number systems are nothing but the normal decimal numbers which we use in our daily life. So let's take an example, say 132. So we know that each digit in this decimal number have some value. This we know, right? So basic math. So in decimal number, each digit holds a value. Say suppose the value is equal to 2 into, so to find the value we just multiply each digit with power of 10. 2 into 10 power 0 plus 3 into 10 power 1 plus 1 into 10 square. That means 2 plus 30 plus 100, which means 132. This is basic math. This we already know, right? This concept.
Yes.
Yeah. Nothing but I'm just multiplying each digit with the power of 10. That's it. So 2 into 10 power 0 plus 3 into 10 power 1 plus 1 into 10 square. Now let's apply this let's apply this with binary numbers also. Let's say if I have a binary number called 1 2 0 1 0 to the base 2. Now I want this value. So what is the value of this binary number? Any idea? Just multiply each digit with power of 2. 0 into 2 power 0 plus 1 into 2 power 1 plus 0 into 2 square plus 2 into 2 cube plus 1 into 2 power 4. Then we will get the value of this binary number.
That's binary. Should not come.
Yeah, I was expecting this. So in binary, we cannot use 2. So the number should be less than 2. Okay, so 0. So it will be 0. So the value will be equal to 0 plus 1 plus 0 plus 0 plus 16, which is nothing but 17. This is in decimal number. 17 to the base.
0 plus 2.
With
The second number should be 2.
sorry. So it will be equal to 18. 18 to the base 10. Is it clear?